Lesson 2.2, Task 3. Define complex numbers. In a complex number, a plus bi, a is called the real part and b is called the imaginary part. Note that the imaginary part refers to the real multiplier of I. It does not refer to the imaginary number bi. The Venn diagram shows some examples of complex numbers. All right, so if you look at the Venn diagram, you'll see that complex numbers a plus bi are written here. These are called complex numbers. All right, real numbers are just like what we've studied in years past. All your real numbers. It can be positive or negatives. It could be decimals. It can be irrational numbers. Square root of 7 and pi are irrational. It can be integers, rational numbers, whatever. Okay, so all of these are considered real numbers. Imaginary numbers now are a product of a number in I. So I, or 2.4i, negative 6i, all of these are I, or a product of a number in I. All right, and a complex number is going to be a binomial written in the form a plus bi, so it's going to have addition or subtraction to make up that complex number. Okay, so imaginary numbers and real numbers are also included in complex numbers, but they have a different subset. All right, so it says choose the type of numbers for each expression. Negative 6i, that would be an imaginary, and imaginary fits in complex. So this would be imaginary and complex number. Negative 5 plus 2i, that's going to fit in your complex. That's going to fit in just the complex number because it's negative 5 plus bi. A plus bi is just a complex number. 14.6, that's going to be a real number. Real numbers are also complex numbers. 0 is real and complex. Now, I squared. I is an imaginary number, but I squared equals negative 1. Negative 1 is a real and complex number. All right, that's all for task 3. If you have any questions, please let me know. Lesson 2.2, task 4. Add and subtract complex numbers. The properties of addition and multiplication, associative property, commutative property, identity property, and distributive property also apply to complex numbers. You can use these properties to operate with complex numbers and simplify the result. When adding and subtracting complex numbers, group like terms to add or subtract the real and the imaginary parts separately. So if you have a plus bi plus c plus di, you can add a plus c, which are your real parts, and then you can add a b plus d, I, which are your imaginary parts, separately. All right, so let's look at an example. If we look at number 4, okay, and I like to do these kind of to the side, so we're going to do 3 plus 2i, and then minus negative 4 plus 7i. All right, so remember the negative gets distributed. If I distribute this negative, then I'm just kind of adding like terms. So I'm going to have 3 plus 2i, and then plus 4. A negative times a negative makes that positive 4, and then negative 7i. Then I can look and I can say this is my A and C, so I'm really going to add these together. So I can add 3 and 4, which give me 7. And then I have 2i minus 7i, which gives me negative 5i. Okay, so I got the same thing that they got. I did it just a little bit differently, but you can see the process that you go through to distribute the negative and then combine like terms. By using associative and commutative property, the order of these doesn't matter. So it says what property allows 2i and 4 to change places. So if I switch to 2i and 4i, that's just commutative property. And it says, which property allows 2i plus negative 7? 2i plus negative 7 to be written as 2 minus 7. So 2 minus 7, that would be the see, 2i plus negative 7. That's just rewriting this in terms of factoring out the I. So that's just distributive property. So a little bit closer look at this. If I have 2i plus 7 or negative 7 here, I. So to rewrite this as 2 minus 7 and pull out the I, so the I comes out, that's just distributive property, because if I put the I back in, it would be 2i minus 7i again. So we're using distributive property in reverse there to rewrite this as this term here, which is this term here. All right, that's all for task 4. If you have any questions, let me know. Lesson 2.2, task 5. Multiply complex numbers. The distributive property holds when multiplying complex numbers, just like when multiplying real numbers. So if we multiply this example here, negative 4 plus 7i times 2 plus 3i, you're going to use distributive property just like we did in the previous example. So negative 4 times both of these terms, and 7i times both of these terms here. So when you multiply and combine like terms, you get negative 29 plus 2i. So it says what property is used to go from this original step here to this step here. All right, so negative 4 times 2 is negative 8. Negative 4 times 3i is negative 12. So we got 7i times 2 is 14i, and 7i times 3i is 21i squared. So that would be called distributive property. All right, so it says, why can 21i squared be written as negative 21? By definition, I squared equals negative 1. Negative 1 times 21 is negative 21. All right, that's all for task 5. If you have any questions, please let me know. Lesson 2.2, task 6. Divide complex numbers. When dividing complex numbers, you need to change the denominator of the quotient to a real number. To do this, multiply the numerator and denominator of the quotient by the complex conjugate of the denominator. The product of a complex number and its complex conjugate is always a real number. All right, this is a definition that you need to know. So make sure you know what a complex conjugate is and what it does. All right, so a complex number can be written as a plus bi, and its conjugate is going to be a minus bi. So whatever the complex number is, you're going to change the sign in the middle, and that's going to be its conjugate. All right, so to simplify, let's look at an example here. And this is a way to rationalize your denominator, because you don't want an imaginary number in your denominator any more than you want an irrational number in your denominator. So if we have 3 minus 4i over 5 plus 2i, first you have to know what is the complex conjugate of this. And you see that you take the same complex number, change the sign, and multiply that on top and bottom. So I'm going to multiply the top by 5 minus 2i. And I'm going to multiply over the bottom by 5 minus 2i. Now, remember I can do this because anything divided by itself equals 1. And if I multiply something by 1, I'm not actually changing it. I'm just writing it in a different form. We talk about that all the time. Rewrite something in a different form. That's a major standard in your math standards. So always rewrite something in a different form. All right, I'm going to put this in parentheses just so it looks like what you've seen before. So you multiply two binomials, you use distributive property. So 3 times 5 is 15, And then 3 times negative 2i is negative 6i. And then negative 4i minus 5 is negative 20i. And negative 4i times negative 2i, that becomes a plus 8i squared. I squared is negative 1, so plus 8 becomes negative 8. All right, on the bottom, I'm going to have 25 and negative 10i plus 10i. Negative 10i and plus 10i, my middle terms are always going to cancel because these are conjugates. And then I'm going to have negative 4i squared. And remember, negative 4i squared, I'll write that down here, but I squared is going to become negative 1, and this is just going to become plus 4. So let's go 15 minus 8. 15 minus 8 is 7. And this becomes negative 26i over negative 4 times negative 1. Remember, I can rewrite this as negative 1. That becomes plus 4. So 25 plus 4 is 29. So you can write this in this form, or you can separate this into 7 over 29, which would be my A, minus 26 over 29i. So you could also write it in this form, which is your A plus BI form. Okay, so that's written as a complex number there. And you can see when we multiply by the conjugates, we get 29 in the denominator, and that is not an imaginary number or irrational number, so that's why we do that. All right, so it says, why can we multiply by the conjugate here? So this divided by this is 1, and anything divided by 1 can be multiplied by without changing the process. Choose one or more of the following that describes why negative 4i squared equals 4. All right, so if I have negative 4i squared equals 4, first thing I can do is say divide by negative 4. And that should be a 4. Sorry, it looks not so neat. So I've got I squared equals negative 1. And then on top of that, I can take the square root of both sides. And I equals square root of negative 1. All right, so I can look down through here and I can see that I squared equals negative 1. And I equals the square root of negative 1. So this one has 2 correct answers there. All right, that's all for task 6. If you have any questions, please let me know.